Welcome to Physics online class. Today we are going to see about nuclear physics part 4. In the last classes we have seen about nuclear fission, chain reaction. In the chain reaction two types, controlled chain reaction and uncontrolled chain reaction, and finally we seen critical mass. Okay, now we are going to see about the next content, atom bombs. Okay, so what is an atom bombs? That atom bomb is nothing but is a instrument which is works on the principle of uncontrolled chain reaction. Already I said in last classes, uncontrolled chain reaction is used in atom bomb. What is uncontrolled chain reaction? Uncontrolled chain reaction is nothing but the number of neutrons and the number of fission reactions multiple almost in a geometrical process in indefinite manner it will goes. Okay, so during this process very large amount of energy will be produced. Okay, so these are all already we seen in the last classes. Okay, in atom bombs there are the two types of atom bombs. One is explosive types, another one is a gun types. Okay, so here we are going to see about only gun type atom bombs. In that explosive types we are going to see in the higher classes. Okay, so here there is a right side diagram. This is a gun type explosive devices. Here is a primary explosive device is here. This is called conventional explosions, and this is a cylindrical injecting type of the device. This is made up of a fissile materials of uranium 235, and this is a cylindrical viad. Cylindrical viad is nothing but viad is a empty space is called a viad. Okay, so this cylindrical viad also made up of a fissile materials which is also made from uranium 235. So these two materials are in subcritical stage because a subcritical stage materials cannot undergo a fission process. Now we are going to see about what is the structure of an atom bomb. The atom bomb is consist of a piece of a fissile materials whose mass is a subcritical. Okay, already I told the subcritical mass cannot undergo a fission process. And another is the piece of the cylindrical viad. Cylindrical viad already told, that is viad means empty spaces. Okay, so in the before slide it gives shown here, this is a piece of the cylindrical material and this is a cylindrical viad. Okay, and these are both are in a subcritical stage. Okay, it is a cylindrical fissile material which can fit into this viad, and the mass is also subcritical. Okay, so both are in a subcritical stage. When the bomb has exploded, okay, so on the initial stages gets triggered. Okay, so once on the conventional bomb gets explode, the injector type of the fission cylinder moves towards this viad. Okay, and fixed with that bomb, and it becomes the two pieces of the fissile material joined to form a supercritical mass which leads to an explosion. Okay, so these are the structure of an atom bombs. Okay, so next we are seeing about that original diagram of a atom bombs. So this is a conventional explosives, this is a detonator, and here this is a cylindrical viad, and this is a cylindrical fissile materials. Okay, so once the explosives, initial explosives gets explode, this cylindrical viad moves towards this kind of the cylindrical fissile materials. They both are gets joined and becomes a super critical stages and produce a fission process. Okay, so what will happen is during these fissions, the tremendous amount of energy is produced. This energy in the form of heat, light and radiations can be released. Okay, so these also can be produced, the heat, light and radiations. Addition to some amount of a high temperature of energy also produced, and pressure waves also produced in the surroundings atmospheres. Okay, and that emission of some hazards of radiations produced. These radiations in the form of gamma rays. Okay, so these gamma rays is affect the living creatures like human beings or as animals. These are gets affected by the gamma rays. So everyone is remember about that as during a Second World War, America has dropped the two atom bombs on Japan at Hiroshima and Nagasaki. Okay, so these two bombs are based on the atom bombs types. Okay, And next we are going to see about nuclear fusion reactions. Already in the last classes we've seen nuclear fission reaction. Here we are going to see about nuclear fusion reactions. Okay, so what does mean nuclear fusion? Fuse is nothing but joining. Fission means breaking, fusion means joining. Okay, so here you are going to join the two lighter mass of the element and it becomes a heavier mass. Okay, so during this process some amount of energy will be produced. These kinds of reactions or these kinds of the radiations is called nuclear fusions. Okay, so the definition of nuclear fusion is the process in which two lighter nuclei combine to form a heavier nucleus is termed as a nuclear fusions. Okay, so what does mean lighter nuclei? Lighter nucleus is nothing but lighter mass of the group element is called lighter nucleus. Here we are going to take as a hydrogen isotopes, that is a deuterons 1H2 and another deuteron is 1H2. These two deuterons are combined to form one helium nucleus. This helium nucleus is comparably higher mass than that of a deuterons. Okay, so during this process some amount of energy will be released. Okay, then there is a pictorial diagram is given, that is deuteron is bombarding with the deuteron. So this is one of the deuteron and this is another deuteron which is combined to form a helium nucleus and also produce one neutron which additionally produce some amount of energy. Okay, so how much of energy will be produced during this fusion process? It's nearly about, that is 3.84 into 10 power of minus 12 joules of energy will be produced during these fusion reactions. Okay, already in the fission reaction we studied that is 3.2 into 10 power of minus 11 joule. Here we have produced that is 3.84 into 10 power of minus 12 joule. Okay, next slide we are going to see about how the energy gets from this nuclear fusion reactions. Okay, so already we know that is a parent nucleus and daughter nucleus. Okay, so here that is the left side of the reaction, this is 1H2 and this 1H2 is called parent nucleus and this 2H3 is called daughter nucleus. Okay, so we combine these two masses, mass of the one deuteron and this mass of the one deuteron, combine these two masses, these masses is called mass of the parent nucleus, and this combine that helium nucleus and neutrons, these masses are combined, which is called a daughter nucleus mass. Okay, so comparing these two masses, the mass of the daughter nucleus is less than that of the mass of the parent nucleus. Okay, so where get masses goes? Okay, so that is explained by the scientist Einstein. Okay, so some amount of masses gets disappear. No, that mass is called mass defect. Okay, so the difference of the mass between the parent nucleus and daughter nucleus is called mass defect. Defect is nothing but is reduced, some amount of masses gets changed, that is called defect. Okay, so these mass defect only convert this amount of energy. Okay, so how can you calculate this amount of energy? By using of Einstein formula, E is equal to mcc square. Okay, so what is m is called mass defect, how much of mass gets disappear, thus mass is changed into energy. Suppose if your 1 gram of mass is disappear, means we have to substitute in that mass, m is equal to 1 gram. Okay, then c is nothing but the speed of light in vacuum, that value is equal to 3 into 10 power of 8 meter per seconds. Okay, so in this slide we have to see what is mass defect. Mass defect is nothing but the mass difference between the mass of the parent nucleus and the mass of the daughter nucleus. Okay, which one is greater? So here that is mass of the parent nucleus should be greater than that of a mass of a daughter nucleus. Okay, so during this process some amount of energy is released. Okay, so that energy is gets from the mass defect. How to calculate the energy? That energy formula is E is equal to mc square. Who is given that formula? That formula is given by the scientist Einstein. Okay, so this formula is called mass energy equivalence formula. Okay, remember children, formula E is equal to mc square. Okay, so next we are seeing what is the condition necessary for nuclear fusion. Okay, so in the earth atmosphere, the earth பார்த்தீங்க அப்படின்னா literally we had some amount of hydrogen is present here, but the nuclear fusion is not produced in our earth. Okay, so why nuclear fusion is happen means certain amount of condition is need. What is the conditions? Okay, so because here that is 1H2, this is one of the nucleus and this is also one of the nucleus. Okay, so both are in a positive charges. Okay, we know positive gets always repel each other. This nucleus is repelled by this nucleus. Okay, how can you join these two nucleus? Okay, so how to a repulsive forces overcome? Okay, simple சொல்லணும்னா இந்த deuteron one repel பண்ணும் because both are positive charge. Okay, and that positive charge just gets repel means we can overcome this repulsive force. We have to give additional amount of energy. That additional amount of energy is nothing but heat energy. If applying that heat energy to this two nucleuses, that repulsive forces gets reduced. Okay, so when nuclear fusion reaction is happen means we have to apply the heat energy to the parent nucleus. Okay, how much of heat energy is needed? Okay, so that heat energy is extremely high temperature is required. That high temperature is level is equal to 10 power of 7 Kelvin to 10 power of 9 Kelvin is required. Okay, va? So nuclear fusion reaction is takes place only extremely high temperatures. Okay, va? So nuclear fusion reactions is also called thermonuclear reactions because at extreme temperature only it takes place. That's why they are called thermonuclear process. Okay, so where we get this kinds of the energy? Okay, so we know that during nuclear fission reactions that heat energy will be produced. That heat energy is around equal to 10 power of 7 kelvins. Okay, so when the nuclear fusion reaction can take, okay, so nuclear fusion reaction நடக்கணும் அப்படின்னா கண்டிப்பா nuclear fission reaction நடந்தாதான் நம்மளால nuclear fusion reaction carry over பண்ண முடியும். Okay children, so and how the stars and suns, these are also produce this kind of nuclear fusion reactions. They are also having this kinds of the temperatures. That's why in the sun and stars are produced the large amount of energy by nuclear fusion reactions. Okay, thank you children, we'll see in the next classes.